So, welcome everybody to Monash Engineering. So hopefully you're all here because you are interested or have heard about engineering and you want to know more about engineering, or you know that you want to go in. And so hopefully this will be about half an hour and we'll have plenty of time for questions afterwards. So firstly, I'd like to acknowledge the people of the Kulin Nations on whose land Monash University operates. We pay our respect to their elders past, present and emerging. And if you are watching this online on a stream, then we also acknowledge the traditional owners of the land on where you are streaming from. So we're here to talk about engineering, and engineering specifically at Monash. But as a little bit of a little bit of insight, you probably want to know what engineers actually do. Okay, so I said that it's a profession where you can wake up every day and know that you're contributing positively to society, and that is absolutely fundamental to everything that we do. We're going to have a little bit about our research, and then we'll have a little bit of a talk about like the kinds of degrees that you can take. There are many different options that you can do in Monash Engineering that are tailored to how you want to progress through your degree in your career. Then we'll have a little bit of look about how we help you to transition from a student engineer all the way through to a graduate engineer, and giving you those skills so that you can hit the workforce running. Okay, so fundamentally, what do engineers do? Well, engineers tackle global challenges, right? So we solve problems, and solving problems sounds like fun and sounds very easy, but when you start looking at the scale of the problems that we're tackling, and you can probably imagine the scale that we're looking at: global warming, feeding the world, making sure the world has water. Clean water is a luxury in probably about 80% of the population has clean water. That means lots of people do not. All right, so engineering is fundamentally about solving these problems and teaching students. We teach students like the complexity of these problems and why it takes hundreds or thousands of people working together towards a common goal to be able to do this, and how to do that, right? If you can conceive of trying to organize hundreds of people towards a common goal with all this complexity, then that's what engineering is all about. So engineering is not a solitary pursuit. Gone are the days where you can invent the last, a HP printer in your garage with a mate. Okay, it still does happen occasionally, but that's not typically what engineering is these days. And through that, we also do this by educating engineers, the next generation of people, right? Problems are evolving at a rapid rate, and so we need more and more engineers to tackle all of these problems. So what are some kinds of problems? So on the left, you've got some what are called grand challenges that the engineering community had come up with since probably about the turn of the century, about the 2000s. So things like making solar energy efficient, providing engineering better medicine, securing cyberspace. So a lot of headway has been made into those. But more recently, these sustainable development goals, which look at not just what we want to solve, but how do we solve these things that benefit all of humanity? So things like no poverty, or food for all, or water for all, or climate action is like obviously at the top of our mind. But some of these things don't look like engineering problems, but they absolutely are, because the solution to these problems lies in humans doing things, new technologies being created and utilized equitably across the world, right? So that's the main difference in how engineering is done today versus engineering in the past. What are some of the things that we've done at Monash? So it wouldn't be a good open day unless we had something to brag about, and we have quite a few things, but I can't list them all here, obviously, because they'd be so long. No, just kidding. Something like, if we're thinking about what's really important in the future, renewable energy, making sure that our energy is sourced renewably with low emissions so it doesn't harm the planet, but that requires a lot of battery storage, right? So you're hearing about these giant batteries springing up all over the place to store all that renewable energy generation so that it can be used in times when that generation isn't available. So part of that is, very recently, you may have read in the news or heard of the lithium sulfur batteries that came out of Monash Engineering. They are much more rapidly rechargeable and have much higher capacity than our industry standard lithium-ion batteries. We also recently set the world record for the world's fastest internet connection. Okay, so yes, it's not just for your kids to get better ping on their gaming. It's actually, we would have seen in this pandemic how critical telecommunications infrastructure is for like the productivity of humanity, right? So that leads into things like lower emissions, because you're not having to travel everywhere to get mundane things done in your work. Automation. So automation is something that can help with human safety. It can also help with making sure that things get done in a timely manner. So over there, we've just had recently a demo of a apple picking robot. Now, it might seem really easy to pick an apple, and it is for a human, but a human has usually been raised for 18 years before it can go and pick and effectively pick apples for productivity. But that's a very hard challenge for a robot to do because there's so many variables. And there was a little commercial venture where we produced an apple picking robot for some farmers. So all of this is made possible because we have awesome staff, right? So we have world-leading experts in many of these areas. As you can see, just down the bottom, like we're highly ranked as an engineering school and engineering sub-disciplines in a lot of these areas. So a lot of this innovation is driven out of the research that comes from being a top-tier university. What else do we offer for students? So aside from working with like top teachers and top students, you have access to great facilities. So we've just built a new robotics lab, and that robotics lab is not just about robots by themselves in general, but we're looking more at the ethical and social impact of robots and how they will be interacted with by humans in a safe manner, in a respectful manner, and there's a whole load of like human factors research that go into that, apart from the technicals, like the technical bits and bobs of the actual mechanics of the robots. You'll notice that there's like just construction going on all over the place in the engineering precinct. We've now got a smart manufacturing hub, which is all about the future of manufacturing. So things like 3D printing, and all these techniques which allow us to do things that we couldn't possibly do previously. This building here, this building was completed in about 2019, and we were all set to be ready to teach in here from 2020. March 2020, then something happened, and we couldn't teach in here for quite a while. Okay, so this year was actually the first year where we've had probably full operations of this building. And as you can see, this is not your traditional lecture theatre space, right? This is designed for the needs of engineers, which is to work collaboratively with your peers. Okay, so everyone's facing each other. Everyone is able to be reached by an expert. So I can come and talk to any student at any point in the room, and we have tutors and demonstrators who filter through and help students during their learning. This actual building was designed in consultation with our leading experts in civil engineering, electrical engineering. All of our input has been put into the actual design of this building. So it's a very green building. There's a lot of passive heating and cooling that goes so that we can reduce our energy consumption. 20% of energy usage in a developed country is used just for heating and cooling to keep our climate livable. That's a massive amount of energy if you're looking at this at a large scale. So anything that we can do to shift the dial on how much energy we use for something like heating and cooling is critical, right? Also, this building is full of sensors that monitor people flow, temperature, humidity, so that we can most efficiently use all these resources. And this is kind of a model for where we see, infrastructure moving to in future. Everything's smart, there's smart systems, and everything is built with sustainability and ethics in mind. So how do you become a professional engineer? So all engineering degrees in Australia are accredited by Engineers Australia, which is our professional body. So we undergo rigorous accreditation requirements. And part of that, involves things like demonstrating that students have learnt teamwork, learnt professional skills, as well as the technical skills, as well as having done some work experience before they graduate. So how does it all start? So in first year, we've just undergone a new first year rollout, actually, this past semester, where we took stock of what the industry needed. We took stock of like where everything is heading, and we redesigned the first year to give students an emphasis on how to do engineering in a sustainable, ethic, and human-centric way, because after all, everything we design is to be used by people, generally. Today, 55% of the world's population live in urban environments or cities, and I don't think we'll have any argument that these cities are largely highly polluting entities. They have caused probably a lot of the problems in waste, in emissions, and you could see them as the source of a lot of the misuse of resources in the world. However, these offer, and by 2050, about nearly 70% of people will be living in cities, and they consume vast amounts of energy. But they also offer us the solution to actually coming through and solving some of these problems. And this is because with scale of people in a particular area, we can do a lot of more things efficiently upon a per person basis. And part of this involves transforming our cities into something called a sustainable smart city. Okay, so things such as having buildings being part of an intelligent, part of your infrastructure being intelligent and being able to make energy saving decisions. So what characterizes these cities? They have smart transport. So you can already see this evolving once we have electric vehicles all over the place. So vehicle electrification saves energy. Smart systems, so if traffic is coordinated, you don't have as much starting and stopping, and people get where they need to go efficiently. You cut down on flights, you make flights more efficient, right? Better telecommunications, better aircraft, reduces energy consumption. Structures, looking at their buildings themselves, fundamentally, can we make them less, can we reduce their carbon footprint? Agriculture is a big one, right? So this is not just technical, but also influencing people to make better choices that are for the environment. Okay, and that's part of what engineers do also. Manufacturing, as I say, the smart manufacturing hub, making these manufacturing less energy consumption. Manufacturing is about 20% of our energy consumption as well. And all of this is backed by, better renewable energy technology and usage of that technology through things like smart grids, right? And so all of this is the context in which we teach our new common first year. Now, when you come here, you do what's called a common first year, where you take a set number of units which are not specifically discipline specific, and you learn a little bit about all the different branches of engineering. You learn things like design thinking, how to come up with the process of brainstorming ideas, narrowing them down to come to a good solution. You learn about structures and materials, software and electrical systems, and the computing and the math that underpins everything. Okay, so after your common first year, you can choose one of 10 specializations to go into. Okay, so if you have a look at the specializations on the slide, they've quite varied. Some of these you may not have even heard of, but they cover most of the areas that impact into those grand challenges and all those sustainability development goals, right? So chemical engineering, civil engineering, aerospace, biomedical, electrical, materials, environmental. Robotics is a very large growth area, mechanical and software. Now, any of these degrees, you can do a double degree with. That's what Monash really offers as a real differentiator. You think engineering, great. I can use this to make a great contribution to society, but I really love music, for example. And I really want to pursue that as like a love of my interest. So you can do arts and engineering. Or if you want to, another common one is commerce and engineering or science and engineering. Okay, so those skills that you get across two disciplines are often really valued by employers. And it just makes you a better engineer with a wider breadth of knowledge about the society in which you operate in. If you don't want to do a double degree, perfectly fine, but you want to still diversify your knowledge, you can do something called an engineering minor. An engineering minor is a set of 4 units which you do throughout your degree, and they've been particularly chosen to fit within a particular theme. So you might take a minor in civil engineering. You might say, I'm doing my degree in electrical engineering, but I think I might want to work in the construction industry, and I need to know a little bit about that, so I could do a minor in civil engineering in that case and get good knowledge in both, but your primary degree would be in whatever you started in electrical. Now this is available in most single degrees, not all of them. There's a little asterisk there that says not available with biomedical or software, but all the other ones you can do engineering minors in. So if that interests you, then that's another good way to go. You don't have to do it, but it's there. So you want to do a master's, right? So what we do offer is something called an accelerated master's program. So instead of doing 3 years and doing a 2-year master's, you can actually do 4 years, get your bachelor's, and then if your average mark is 65 or above and you've taken the right subjects, you can actually get the master's credit for 1 extra year. Okay, so this is called the accelerated master's program. What else can you do on the postgraduate side? Well, some of you may be joining us and you may have already done like a 3-year science degree or computer science degree, and you might find that, okay, science was great, but I really want to get into applying my skills and making an impact in the industry, applying your sciences. So in this case, you could basically do an engineering degree in 3 years instead of the usual 4. You get credit for units that may be common as well, and that's called the Master of Professional Engineering. So then you get an accredited master's degree in this case. And for some other students, if you've already done like an engineering technologist or a Bachelor of Engineering somewhere else that is not recognised as by Engineers Australia, you can do a 2-year master's and get full accreditation as well. So this isn't a large cohort right now in here, but I do know that there are some people who would be very interested in this. Let's say, like we've talked about, like engineering here as a profession and being a professional engineer, but there are other ways engineers can make impact as well, and that's through, if you want to be on the cutting edge of engineering, so you're not maybe in the operational side, or the implementation side, but you want to be on the research side, then you can do either a research master's after your undergrad, or you can do a Doctor of Philosophy, a PhD. And this typically is where you're doing engineering right at the cutting edge of the field. So, your insights into, you might be really focused on one particular problem. This is what a PhD is. You're really focused on a particular problem, and you're so focused that you know exactly all the details of the problem and where you can make an advancement in the field which nobody has done before. Okay, and so then those kinds of discoveries then lead to things being filtered through things like commercialization. And that's what the postgraduate research degrees are all about. So if that interests you as well, then this is definitely a path that you can take. What about industry engagement and applied learning? So every accredited engineering degree in Australia has to have a requirement that their students undergo at least 420 hours or 12 weeks of engineering, of work experience, 50% of which must be engineering related activities. So to become an engineer, we make sure that you have to be able to work professionally. Okay, so this may not just be specifically technical things, but things like being able to work in teams, communicate effectively in verbal or written communication. These activities you can get through employment. Okay? Now there's a number of ways to do this. To get this 420 hours requirement, you can get this through a number of programs that Monash offers. I'll talk shortly about those. They're called the Co-op, Summer Research, Mighty program. You can organise your own internships working with engineering-related industries. Other engineering programs such as volunteering with outreach or something like that, they can count towards some of these CPD hours. And then finally in red, there's something called the engineering teams and clubs. We'll talk more in depth about that very shortly. So over here are some of the options. Now these are real differentiators with other institutions. The Co-op program is a flagship program at Monash where it's competitive, but we will get you 3, 6 or 12-month paid internship working on real world projects with Australian or international companies. Now it is competitive, but if you're successful in that, you get training to go into the industry, and we're growing the number of companies that are opting into this program to take students. And often these companies will hire the students on a part-time basis after they've finished their internship, and then hire them directly after they've finished their degree. This is a large source of recruitment of talent for them. So typical companies like Metro Tunnel, the Rail Crossing Removal Authority. You've also got the Suburban Rail Loop coming up. So there's a lot of infrastructure work going on around Victoria where they will take any bright students help to get things done. In the master's program, there are units that you can take which are specifically with internships, but you get credit for it, not so much in the undergrad program. And then there's something called the Mighty program, which is like the Co-op program, except it's not just engineering. So Mighty is the Monash Industry Team Initiative, and industry comes to the university as a whole and says, hey, we'd like 5 students to come and help us to solve this problem. Like they're paying student rates, but the program will then get students from across disciplines. So they might get a marketing student, a commerce student, a couple of engineers, and a software student. And then they come and solve problems for the company. So like companies like NAB or ANZ have made use of this in the past, and various other industries as well. If you want a bit of idea of research, the engineering faculty has a summer research program where you can work with academics to do a small aspect, contribute a small aspect to their bread and butter research. And then you can get an idea if research is a path for you. And over here, so if you don't manage to get an internship or do anything with the Co-op or Mighty or anything like that, the other option you can do that we help students to get these CPD hours is actually these engineering teams and clubs. Now you might say, engineering teams and clubs, that sounds rather social, and it sounds rather, like, having pizza and having a drink and just having some fun. That's not what engineering teams and clubs are. Engineering teams and clubs are built, they're like small companies. So I think the motorsport team has about 150 members, and they have a corporate structure. They have like a president, vice president, head of operations, head of human resources, head of marketing, head of outreach. So they run like companies. And so in doing that, students get a real taste of what it's like to work in an engineering environment, because you need the same skills to run these little, operate in these student teams and clubs as you would running in a corporate organization. So what are some of the examples of these clubs and teams? So over on the left, you've got a building there. That's the solar decathlon team, and they build buildings. They design and build structures, and actually build the structures, so they have to go through all the processes that you would need to go through to get a structure built. You need planning permits, building permits, you need to source materials, you need to design the structure, you need to make it so it's like conforms to energy rating standards, and it's a competition. with other universities to make the best structure. We've also had in the news recently the carbon capture and conversion team. They're tasked with, their mission is to come up with ideas and implement ways of capturing carbon out of the atmosphere and making sure that it doesn't go into the atmosphere and help hinder us with global warming. And they actually won $250,000 from the Musk Foundation to actually implement and try out their ideas on a larger scale. High-powered rocketry, as the name suggests, they make rockets. They actually went overseas very recently. You may have seen it on the news where the team went overseas and they're all enthused and ready to go, and their rocket got left by Qantas or Jetstar, I can't remember which it was. It got left somewhere and they had to have a mad scramble to find the rocket, and then the rocket had to go through, and then I heard they had to send somebody to actually physically go to receive the rocket at a different airport to where they were. So I was just like, but through all that, they managed to come second in the worldwide competition in one of the categories and 6th overall. And this is a worldwide competition. You're going against the Princetons, the Harvards, the MITs, the Caltechs, all of those institutions. All right. So these teams are real serious, engineering teams. Monash Motorsport, you might have a look outside later. You might have seen the electric vehicle. I'm sorry if you're into motorsport and you really love the revving and that's what really gets you going. The electric vehicles are very fast, but they're quite quiet, which is quite interesting. So the Monash Motorsport, they've had a long-standing, they're a long-running club, long-running student team, and they basically win everything. As in the international competition every year, they go different places. Their combustion vehicles usually wins. They've branched out into different vehicles, electric vehicles, and also autonomous vehicles. So basically, every year they build a new sports car, a new Formula SAE car. And doing that from scratch, you might appreciate, is a very complicated engineering feat. And doing that and basically leading the world in that is also very impressive. Precious Plastics, they're one of our cool outreach clubs. They have on a trailer, they have a full recycling plant. So they drive out to schools and say, hey kids, bring all your plastic rubbish. They shred it on the spot. They reforge it on the spot into interesting trinkets and things for, to demonstrate to primary school and secondary school students the recycling cycle. Rover on the left, they make basically, if you've heard of the rover's Curiosity that had landed on Mars, maybe last year or the year before, that's basically the model for Rover. So that's an international competition where universities send teams of students to make a fully autonomous rover that can go and collect samples from the area, send information back to home base, basically simulating the conditions on Mars. So I think a couple of years back, they ran into a mishap on transport of their rover, and there was some key learnings there about securing things down and things bumping around in the desert. But they still came 10th that year. I think this year they came 2nd in the overall Rover challenge. So it takes a lot of engineering expertise and engineering support from the university and the advisors as well. Then we've got other clubs, MedTech, so this is more biomedical flavored. So looking at how we can use engineering to interface with health and coming up with cool ideas. That's what our MedTech innovators do. The Forge is a materials and mechanical flavored club where, as the name suggests, they forge things. Not forge as in fraudulent forge as in make things out of metal and alloys. And everything from replica Thor's hammers to shields and armor, for instance, if that's something that interests you. Robogals, you may have in school, you may have come across Robogals. They're an outreach division where they exist to enthuse students about engineering and robotics. Some of you may be here because you've participated in Robogals programs. Deep Neuron is a bit more software and electrical focused, where they're applying artificial intelligence and machine learning to any and everything that they can think of, whether it's optimizing the scheduling of when lights come on and off in the building, or high-powered computing, optimizing high-powered computing. That's what they do. And then we've got a chemical engineering flavored one down there, the bottom right, Brew Lab. So they basically make homebrew beer, and they tweak the chemical compositions of their brews to make something that's palatable, and they sell it. So they have to go through all of the regulatory requirements of, selling, get licenses, do marketing, commercialization. So, the range of activities that you do in these student teams and clubs are of a professional grade. That's why they count towards these CPD hours. And so students can be part of these clubs, any of these clubs. How do we support these students? Well, we have across, if we go out that side of the building, there's the makerspace. You may have already had a look. So we support the students by giving them world-class facilities to be able to make things that they want to make and design things and have the expertise to support them to bring their ideas to fruition. Okay, so they have all sorts of fabrication, machining, sanding, welding facilities for these student teams and clubs. For the non-student teams and clubs, we have the design and build studios. If you go out that door, just at the entrance where the big stairs are over there, you can see these are the students, these are teaching labs. They have arrays of 3D printers. They have whole full suites of electrical equipment and oscilloscopes and all sorts of items required for electrical work. They have a sewing room. They have welding bays, spray booths, sanding and cutting, everything that you need to do hands-on engineering. And this is available to all students as long as you complete the safety inductions. Right? Safety is the #1 concern in using any of these facilities, so we take that incredibly seriously. So where do our students work? So a lot of these, these are the typical engineering areas, engineering companies where students work. Some of them you may not think are engineering, so like something like Maya. Why engineers working in Maya? But they do, as engineers as well. So it turns out that the engineering degree equips you with problem-solving, training. You're trained to look at things in a certain way, which you can't really go back from, unfortunately. So I can't sit there and just appreciate the aesthetic beauty of a particular thing anymore, because I have to look at it and go, oh, how could that be optimized or whatnot? So that way of thinking, it turns out, is quite useful to any industry that has a problem. So if you have a problem and I'm good at looking at a problem and decomposing it into something that can be solved, then an engineer is very highly desired to help you solve problems. One other thing is there's this thing called the Monash Generator. And the Monash Generator is a university-wide thing which helps startup companies. Well, its mission is to help students and staff to turn really cool ideas and good ideas into commercial products, in commercial products. So, so many ideas get generated out of engineering. It may be coupled with other faculties as well. It might be software and hardware together. It might just be process improvements or things that people find just really good ideas. So the generator is there and bringing in that expertise of startups. And how do you run a startup? How do people do the marketing? How do people raise capital from investors? And so the generator is there, and we engage with them a lot to take student inventions into market. Employment careers, so some numbers, like everyone loves numbers. Like all our graduates, 83% of graduates are in full-time employment within 4 months of graduating. So this was from a survey from 2021. Average engineering salary was about 116,000. If you want to look at the growth areas, like all engineering is required because there's just much more work than we actually have engineers to do. But particularly growing areas in LinkedIn were artificial intelligence specialists, robotics engineers, and automation consultants, if you want to look at the hot areas at the moment. But these things change, they go through cycles when we get enough of a certain type and others are in demand. What kind of industries do people work in? So often people go, oh, if you do electrical engineering, where might I work? Well, the answer is you could work pretty much anywhere. So our graduates, there are core industries that take engineers, like mining, manufacturing, utilities, construction, information, media, telecoms, all those kinds of things. They're your traditional, what you might think of when you think engineer. However, at the last census, where you fill in your occupation, like where your highest qualification is and where you're actually working, there is a large amount of growth in non-core engineering industries. So education and training is employing a lot of people who have engineering degrees. Warehousing, distribution, healthcare, admin, retail, forestry, all these kinds of fields have registered in the last census as having qualified graduate engineers working with them. And it turns out that wherever there are problems is where you can find engineers working. Right, and there are a lot of problems in the world. Okay, so that's it from me for the talking part. And our friendly student services staff will have a couple of microphones to take some questions from the audience. I'll see if there are any questions on the Flux link. What degree did Tony Stark complete? Because I'll do that. That's a good one. I'd say probably mechatronic-y type work, I would say. I dropped out of Monash Engineering in 1986 after being made to build a suspension bridge out of spaghetti. Spaghetti is gone. We use 3D printing for that now. What's the lowest ATAR that you could get in with? So the minimum ATAR last year was 87 or so, 86, 87. But you probably want to be a little bit higher than that in the coming year as well. Is Monash a TAFE? I don't think the provider is classified as a TAFE. Are there any LGBTQI plus people that do engineering? Yes, absolutely. There are heaps. There is an LGBTIQ club as well. And we take this very seriously at Monash in general and Monash Engineering. So yes, engineering is a very welcoming community.
Yeah, and I'm an ally of the LGBTIQ community. I'm an ally, and my team are as well. We've gone through all the training to make sure that we support the LGBTIQ community.
Is most of the study online or in person? So we only had online for students who are trapped overseas. They can't get to Australia. And those numbers have dropped dramatically. I think this semester I only have 2 students in my unit of 500 that are doing online only. Everyone recognises that in-person is the way to learn. And so all our classes are in-person first. Any questions from the audience? Stick up your hand if you have a question. We've got a couple of microphones roving around. No? Okay, I'll take a couple more.
I just wanted to ask, concerning the recent immigration in Australia, what is the ethnicity ratio of Indian people in the engineering course?
I have no idea. Well, I know that India, it was the largest international intake.
Yeah.
because we basically have 0 students coming in from China at the moment, but these things change from year to year.
Thanks. I just had a question. Do you have to make the decision on the double degree at the start, or can you make the decision during the course?
Do you want to answer that one, Andrea?
Yeah, do you mean the specialisation within the double degree or the decision to pursue a double degree? The latter. The latter, okay. So there are 2 options there. The first option would always be preferable to choose your double degree at the beginning. So to use open day to get the opportunity to get as much information as you can about what you want to pursue. However, if you get into a single degree and you decide that you want to pursue a double degree, there are options for transferring after 1 year of full-time study. This is for engineering only. Different faculties may have different requirements. So you'd need 1 year of full-time study and you'd need to meet a minimum average. So if you've done a single degree in engineering or somewhere outside of engineering in university, you need a 65% average as a minimum and 8 units of study to transfer. That's for consideration, but depending on the number of places, that minimum might be a little bit higher.
Yeah. It's easier to transfer from a double to a single than it is from a single to a double as well.
If you've gone into, say, a double with another faculty and you decide that you don't want to do the other faculty component, unless you're not performing well, it's pretty much guaranteed because you're already technically in the degree. Yeah. But going the other way, you're kind of not in the degree.
No, here's a question.
I just want to know about international exchanges and can you do like the units you do here overseas and like count towards your degree time here?
Yep, absolutely. So Monash operates a study abroad program across the whole university where we have agreements with partner universities the units are matched typically, like we do assessments of the destination universities units. If they match for credit, then you can take that unit for the same credit here, absolutely. And that's something that we can highly recommend if you can do it because it broadens your experience, broadens your knowledge, broadens your ability to empathise with other people.
When do you do the industrial placement? How long do they go for?
So you don't have to wait. You can do, typically students will do it after 2nd year where they've got a little bit of expertise from their specialisation. Doesn't mean that students can't do things after 1st year. The co-op program typically only takes students after 2nd year, the later you go, the more. There's also like employers come through with job fair days as well. They're organised things that the university runs where you speak to prospective employers about internships and stuff. How long do they go for? It's completely dependent on you and the employer. Yep. So some students do part-time work with actually study part-time and work part-time. Some students do a 3-month internship over summer, so that doesn't interrupt. So some might do 6-month internship where they take a whole semester off. So the options are very flexible.
What's the learning and teaching environment? So this is a massive room. Would you have this room filled with first-year students in that college?
Absolutely, yeah. So
Lectures, seminars, tutorials?
all of the above. So whatever works for the particular content that's being taught, depending on, and also has to work with the available resources we have. So in something like this, we might be, if we're teaching coding, for instance, we would have students working together on their tables, solving coding problems and having tutors and demonstrators filtering through, assisting students wherever they get stuck. They might then work on their problem for a little bit and then bring their attention to the lecturer at the front who might run through some concepts, all the while taking feedback from students via things like the Flux code here, where students can ask questions and answer questions that we pose to students. So that's typically how it starts in 1st year, because the numbers are so large, because everyone's doing the common units. But then as it progresses later and later, as the class sizes get smaller and more specialised, then you might find in a smaller elective of say 30 students where the academic is looking at really technical specialisations, then that person might be with the students for the whole semester.
engineering at Monash better than places like RMIT or Swinburne?
So the answer there, I would say, is the advantage that we would have is that we're working with those world-leading experts on the research side. So that research then comes into and informs the curriculum that we teach, as well as having those people who have that ability to do the research, but also then translate that into like cutting-edge teaching as well. So teaching-intensive universities are great. They serve a really great purpose. Research-intensive universities are great too. They serve a different purpose as well. I think Monash is, one great thing about Monash is that we have both. So, like you can see that we have the facilities and the expertise to do a lot of hands-on engineering work, but we also have those worldly experts to push the boundaries of the theoretical work, which then bleeds back into the teaching side too.